Alright, welcome, and this is my walkthrough of my program for the color channels, color tracking and various drawings. I'm unfortunately unable to show any of the output videos examples as my webcam doesn't work, and I haven't been successfully implementing the code into OpenFragWorks video loader. But the code should work as it's been tested by people who have working cameras. Right, so we'll start off with the color channels. In order to create a color channel, you have to change the two other colors into the same as the one you want to channel. For example, if you want a red color channel, you set the green and blue color to the same values as the red color. This will put a red filter over the output video and everything will appear red. When making green and blue color channels, it works the same as the red, where you set the corresponding colors to the value of the color you want to channel. Moving on to color tracking. Color tracking works by going through the double for loop and checking every pixel's color by putting up a threshold or criteria that it has to fulfill in order to be considered red in this example. If the pixel meets the criteria, its color value is set to 255 or white. Every pixel that doesn't meet the criteria is set to 0 or black. This way the output video will show every pixel that is the color you're tracking as white and everything else as black. There are several ways of tracking color. Some are simpler and allows for only strong colors of red, green and blue to be tracked. Others are more complex, which uses complex math to calculate different color nuances for a larger variety of color tracking. For example, this code uses complex math to calculate a color is red for different nuances. It will be able to track bright and dark red, whereas a simple color tracking code wouldn't be able to. Both have their advantages. The simple code can be set to only track an object that meets the criteria that the program has chosen, but it won't be a good example if the programmer doesn't know the exact nuance of the red color that he wishes to track. In that case, this code shown here is better, as it is able to track red color over a larger scale from bright to dark red. Green and blue color tracking works the same as the red, where it just focuses on tracking either green or blue instead of red. Moving on to finding center of mass. In order to find the center of mass, you have to take all the pixels of one color and divide it with the sum of all the pixels. The double for loop checks for every pixel that is beside it of the same color. In this example, red. And whenever it finds one, it counts one up in the number of pixels. Then at the end, it divides all the red pixels that is neighbors with the total count of red pixels. The plus 0.1 float is set there to make sure that the program doesn't divide by 0 and crash. Again, as the color channel and color tracking, this is the same for green and blue, but instead of checking for red, it checks for green or blue. We were asked to show in the output video across where the center of mass is. In order to do this, we use a draw function that is included in the movie grabber. Offset color 255.0.0 tells that we want to draw with a red color, since it's RGB. I got an error in my comments, the B and G is switched around. I use the offline function, which draws a line between two coordinates. Mine is set to start in center of mass x minus 20, center of mass y, and draws the center of mass x plus 20 to center of mass y. This means that it will draw a line 40 pixels wide going through the center of mass on the horizontal line. The other off line draws the same line but this time vertical. This will together create a cross indicating where the center of mass is. But just showing where the center of mass is wasn't enough. We should also show the exact coordinates too. In order to do this, we use two strings, one for the x coordinate and one for the y coordinate. First, we create two strings that write center of mass x, and then we feed the information to the string, which can be updated with the movie grabber main loop. And the information that is fed to the string is the constantly updating center of mass that we defined earlier. Then we use the draw function to draw it on the screen. First is the string's name, in this example center of mass x and center of mass y, and their coordinates where they should be drawn. This will draw the two strings below each other in the upper left corner of the screen. Then we should have a sprite following the center of mass. In order for this to happen, we first have to tell the program where to find a sprite. For this, we use the load image, which we stole from the image loader, and tells it to load a sprite that we place in the movie grabber bin data images. Now we have an image of sprite. It is called sprite in our code. Now we have to draw it on the screen and give it some coordinates to tell exactly where it should be drawn. For this, we go back to our draw function again, and simply tells it to draw our image, the sprite, at the coordinates center of mass x minus sprite width divided by 2, center of mass y minus sprite.height divided by 2. This will center the sprite in the center of the mass. If you just told the sprite to be drawn in the center of mass x dot center of mass y, then the sprite would follow the center of mass with its upper left corner instead of being centered. This was my walkthrough of my program for color channel, color tracking and drawing.